Hello, I'm Jim Kelly, and I'm going to show you a very pretty proof that the number of prime numbers is infinite. We'll use just a little arithmetic and some very clever mathematics. We're going to approach this question: how many prime numbers are there? So that's a big question. How do we go about finding out? Well, first of all, what is a prime? A prime is a number with only two divisors, itself and 1. So 2 is a prime because there are no other divisors besides 2, and 1 goes into everything. 3 is a prime number for the same reason. 4 is not prime because it's 2 times 2. 5 is a prime number. 6 is not. 7 would be. 8 is not. 9 is not. 10 is not. 11 is 1. 13 is 1. 14 isn't. 15 isn't. 16 isn't. 17 would be the next one. So there's obviously a lot of them. But the question is it an infinite number? So the way we're going to approach this is to use a very clever method of mathematical proof. And it's called RAA proof. Reductio ad absurdum. Reduce to an absurdity. And the way that method works is you make an assumption and then you attempt to disprove your assumption. If you can disprove it, the opposite of the assumption is true. So it's a backward proof, but a very powerful method of proving something. So I'm going to make the assumption that there is a biggest prime number, and I'm going to call it P. Now, I'm going to try to prove that's incorrect. So how do I disprove that P is the biggest prime number? I start off with a new number, n, and n is going to equal 2 times 3 times 5 times all the primes. And the biggest one is P, so the last one would be P. So that's n. And now, is n prime? No, it's not, because if you divide this number by 2, these 2's would cancel. It goes evenly into this number. If you divide it by 2, what's left is 3 times 5 times 7, etc. If I divide by 3, it divides evenly, and what I'm left with is 2 times 5 times 7, etc. So this is certainly not prime. It's one of the least prime numbers you could imagine. So make a new number, Q. And Q is going to equal n, this number here, 2 times 3 times 5 times 7, P, plus 1. So it's just n plus 1 is Q. And the question is Q prime? To find out if Q is prime, let's divide it by one of the primes to start with. So Q is equal to n plus 1. This n plus 1. Let's divide it by 7. And n plus 1 over 7 is the same as n over 7 plus 1 over 7. Now we know that 7 goes into n because there it is in n. So it's going to cancel, but it won't it leaves a remainder of 1/7. And therefore, 7 doesn't go into Q. Neither does any prime for the exact same reason. And therefore, neither does any number, because the fundamental theorem of arithmetic states that all numbers are composed of a product of primes. So therefore, Q is prime. And Q is much bigger than P because there's P inside Q. And therefore, our initial assumption that P is a biggest prime number is incorrect. There is no biggest prime number, and therefore, the number of primes is infinite. I think that's a very pretty proof, and it shows the power of basic mathematics. Thank you very much.